Have you ever stood on a beach, wiggled your toes in the wet sand, and had a really weird thought pop into your head? Like, if the ocean is just a giant bathtub sitting on all this sand, why doesn't all the water just leak out? It seems like a simple question, but the answer takes us on an incredible journey deep beneath the ocean floor. Let's start with what we see. When you're at the beach, the sand looks like it goes on forever, right? But that's just the very top layer, like the frosting on a massive, geological cake. This sand is mostly tiny bits of rock and minerals, like quartz, that have been ground down by waves and weather over millions of years. It's loose and porous, which is exactly why water seems to disappear into it so easily. If the whole ocean floor were just a giant sandbox, you're right, the water would eventually seep away. But thankfully for all the fish, and for us, that's not the whole story. So, what happens if we could dig down through that sand? Well, as you go deeper, the immense weight of all the sand and water above starts to press down. This pressure is incredible. It squeezes the sand grains together, reducing the spaces between them. The deeper you go, the tighter it gets. Think of it like a sponge. When it's loose, it can hold a lot of water. But if you squeeze it really hard, you close up all those little holes, and it becomes much harder for water to pass through. The sand deep under the seabed is so compacted that it is more like a soft rock than the fluffy stuff you build sandcastles with. But that's just the first line of defense. Keep digging, and you'll hit something even more solid. Beneath the layers of compacted sand and sediment, you'll find clay and silt. These particles are way smaller than sand grains. Imagine trying to pour water through a bucket of baseballs versus a bucket of fine dust. The water would rush through the baseballs, but it would get stuck on top of the dust. Clay is like that microscopic dust. Its particles are so tiny and flat that they stack together like a deck of cards, creating a nearly waterproof barrier. This layer of clay can be meters, or even hundreds of meters thick, acting as a natural liner for the ocean basin. It's nature's very own high-tech sealant. So we have compacted sand, then a layer of super sealing clay. But the real foundation of the ocean floor, the bedrock of the whole system, is, well, it's rock. Specifically, oceanic crust. This isn't just any rock, it's primarily a dense, dark volcanic rock called basalt. This crust is formed at mid-ocean ridges, where molten magma from the Earth's mantle rises up, cools, and solidifies. Think of it as the ultimate, solid floor of the ocean basin. This basaltic crust is incredibly thick, averaging about 7 kilometers, or about 4 miles, from top to bottom. Compared to this solid rock foundation, a little bit of water trying to seep through sand is no challenge at all. The oceanic crust is the true bottom of the bathtub. Now, you might be thinking, okay, but isn't rock sometimes cracked? What about faults and fissures? That's a great point. The Earth's crust is not perfectly smooth or unbroken. There are indeed cracks and fractures. And yes, some seawater does seep into these cracks in the oceanic crust. This process is actually super important when the cold seawater gets down into these cracks near volcanically active areas, like those mid-ocean ridges. It gets superheated by the magma underneath. This creates something amazing: hydrothermal vents. You might have seen videos of these deep-sea chimneys spewing out black, smoky-looking fluid. That's the superheated, mineral-rich seawater being shot back out into the ocean. So, not only does the water not leak out of the planet, but in some places, it goes on a little field trip into the crust, picks up a bunch of minerals, and then gets ejected back out, creating unique ecosystems for bizarre and wonderful deep-sea creatures. It's a circulation system, not a leak. Let's put it all together. Imagine you're making a layered dessert in a glass bowl. Your bowl is the solid oceanic crust. You then put down a thick, dense layer of chocolate pudding. That's your clay and silt, stopping anything from getting through. On top of that, you sprinkle some crushed cookies, which is your compacted sand. And then finally, you pour in the liquid jelly, which is the ocean water. The jelly isn't going to leak through the pudding, and it certainly isn't going to leak through the glass bowl. The ocean works in a very similar way, just on a planetary scale. It's also important to remember the sheer volume of water we're talking About. The oceans hold about 1.35 billion cubic kilometers of water. That is a mind-bogglingly huge amount. Even if there were some minor seepage happening over vast areas, it would be insignificant compared to the total volume. Plus, the Earth has a water cycle. Water is constantly evaporating from the ocean's surface, forming clouds, raining down on land, and flowing back to the sea through rivers. It's a closed loop. The water isn't going anywhere, it's just moving around the planet. So, the next time you're at the beach, marvel at that sand. It's not a leaky plug, it's the very beginning of a complex, multi-layered system designed by nature over billions of years. A system of compacted sediment, impermeable clay, and a solid rock foundation that holds all the world's oceans in place. The sea doesn't run out because it is sitting in one of the most secure containers imaginable, the Earth's own crust. It is a beautiful example of how simple questions can lead to some truly profound and amazing answers about how our world works. Thank you so much for joining me on this deep dive beneath the waves. If you enjoyed this journey and want to explore more curiosities about our incredible planet, don't forget to hit that like button and subscribe for more adventures. Let me know in the comments what other weird questions have popped into your head. See you next time.